Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Now, I'm going to show you the process on how we need to debugging for the lab 1 part B. So now, as we can see here, I already code the part B for our lab. And in order to make the process debugging, first of all, we need to compile it first. So let's compile our code. So as you can see here, when we compile, it shows that build is 1 succeeded. Means that we managed to compile our code and we have no errors. So when we have this kind of information, we can start to debugging. And you can just start debugging by press F5 or just click the debug and press start debugging. Okay, as we can see here, we have totally of 4 windows, which is memory, autos, watch, and registers. Memories shows us about the variable, about the data that contained on that variable. For example, if I want to check what contains in the val1, I can just write and press N val1, and as you can see here, it shows that val1 contains 00, 01, 00, 00. Okay, why did I read it like that? Because we follow the Little Indian format, which is this kind of information means that val1 contains 10,000 hexadecimal. So when we move to autos, basically it's a windows that shows what happened during the process of the execution, while watch is actually a real-time update on what happened between the variable and the data contained in it. So the registers is basically just to show all the registers that we have and what's the value that they contains. So in order to check the process of debugging, we need to put our breakpoint into our first line of execution. So as we can see here, I will put the breakpoint to the line number 17. So what will happen here basically when I run it, when I execute it, is val1 contains the data of 10,000 hexadecimal, which is it will goes and move to the register AX. So then register AX will contain the same input as val1. So let me show you by press F10. As you can see here, our register AX right now contains the value of 10 hexadecimal because of this line of executions. Move EAX val1. Now, if we execute the next line, basically we will add a value of 40,000 hexadecimal to our register AX. So from 1,000 hexadecimal, it will change to 50,000 because 1,000 plus 40,000 is 50,000, right? So press F10. And as you can see here, yeah, it's totally changed into 50,000. Now, on the third line, we're gonna use the command name subtract. By using this command, we're gonna use value 3, which is 2,000 hexadecimal, and subtract it with register AX. So basically, the value contained in register AX will subtract the value that contains in the val3. So let me execute it. I press F10. Yeah, so from 50,000 hexadecimal, it changed to 30,000 hexadecimal because we already subtract it by 2,000 hexadecimal. So in this final line, we're gonna show that the value that contained in register AX will be moved to the final val, which is, we can see here, our final val is totally 0. And if we check in the memory, also in the memory address, and first n final val, it initially 0. So when we run this line by press F10, you see it's already changed to 30,000. Why? Because this line executes register AX to move into the final val. So if we execute the line call dump register, it's gonna display all the register value in our command prompt. So as you can see here, our register AX right now is 30,000 hexadecimal. So I guess that's all from me, and let us move to part C.
Assalamualaikum and hi. Today I will show the debugging process for lab 1 part C. So before we start our debugging process tracing, I will compile back this instruction code, and also I will rebuild back this instruction code so that this code will not have any error. So as we can see, our code right now success and 0 error, so we can start our debugging process. So we will use the step over to trace one by one what will happen to our memory and also register. So before we start our debugging process, we need to open all the 5 window, which is watch, autos, memory, and also register, and also the assembly. So as we can see here, I already set all the variable that we want to trace. So value 1 until value 3, it has its own value, then 1000 hexadecimal and so on. And right here, if we want to confirm back the value for the variable that we declare, we check back in the memory right here. We write ampersand and then value 1, so we can confirm that the value for our variable value 1 is 1000 in hexadecimal. The order is right like this because it is arranged by a little endian order. So let us start our debugging process. So we will start by pressing F10, step over. So it will start in line 22 as our breakpoint, and then when I execute it, so the value of AX before this, it has some value, and now when we execute the value here, it moves the value of value 1 into the register AX. So right now our value for register AX is 1000 in hexadecimal, and then we execute again, and then same like the instruction, it will add the value of value to variable into the register AX. So now our value is 5000, and then it will subtract the value of AX by value of 3, which is 2000, and right now our value is 3000. And then for line 25 here, the value of our register AX right now will be moved to our final value variable, which we declare right now is 0. As we can see in our watch also, final value W, it has 0 value. because we initialize the value is 0, and then when we move the value of AX into the final value variable, and then when I press F10, so we can see the value of AX 3000 hexadecimal just now just move to our variable final value. So if we check back in our memory, we search $final value W, and we can see right now the value is 3000 in hexadecimal. Okay, moving on to the next code. This is we trace the value B, so we can see the initial value for all the value B. It has 10, 40 and also 20 hexadecimal, and our final value for B is 0, same as above. And right now when I execute this instruction, so it's same like the above code. The value of B1 will move to register AH. So right now our register AH has a value of 10 hexadecimal, and then I execute again. I press F10, and then our value of AH become 50 because we just add the value of value B2 into our value for register AH, and then I execute again. It will subtract the value of AH by value B3, and then line 31 same as line 25, which I store back. I move back the value of here. Our AH register right now has 30 hexadecimal, and then this instruction will move the value of AH into final value B. Right now our final value B is 0, and then when I execute it, I press F10, it will change to 30 hexadecimal, and then line 32 it will display in command prompt our register. So I think that's all for the debugging process for lab 1 part C. Thank you.